Hi, and welcome back to another demo of the UK electrical simulator. In this video, we are going to continue exploring the Megga Meter, but this time we will use its current measuring function on a lighting circuit. First, let's take a quick look at the features available when the meter is set to current mode. There are not many controls to worry about here, which keeps things nice and simple. Once current is selected in the main drop-down box, the second drop-down allows you to choose whether the reading is shown in amps or milliamps. In a previous Megga Meter demo, we used two probes connected to terminals to measure the resistance of a wire. You may have noticed that, in current mode, there are no probes to connect. That is because current is measured differently. With voltage and resistance, we measure across 2 points. But with current, we measure the flow through a conductor or component. In the real world, that would normally mean breaking into the circuit and placing an ammeter in series. Another common method is to use a current clamp. A clamp allows us to measure current on a conductor without disconnecting it. In our simulator, that works particularly well because we are using individual wires rather than full cable runs, so the clamp can be placed directly onto a single wire. To show how the clamp works, I'll quickly add 3 connectors to the workspace, along with 2 wires, one vertical and one horizontal. We are not measuring any current yet. This is simply to demonstrate how the clamp attaches to wires in different orientations. To add a clamp, press the clamp button on the meter. A clamp will appear on the workspace labelled Clamp 1. Just like the probes in resistance mode, each meter gets its own matching clamp, so if you add a second Megga Meter, its clamp will be labelled Clamp 2, and so on. To use the clamp, simply drag it onto the wire you want to measure. When it attaches successfully, the LED on the clamp will turn green. If you place it onto a vertical wire, the clamp will automatically rotate to match the wire direction. If you ever lose track of where the clamp is on a busy workspace, just press the clamp button again and the clamp will flash, making it easier to spot. And if it glitches or disappears off screen, press the small button at the top right of the meter to return the clamp back beside the meter. Now let's see the Megga Meter working on a real circuit. I'm going to load a saved lighting circuit into the workspace. We created a similar circuit in a previous demo, but this version already includes 3 Megga Meters, each set to current mode. Each bedroom light in this example uses a 5-watt energy-saving lamp, so the current values will be fairly small. For that reason, it makes more sense to switch the meters from amps to milliamps using the second drop-down. Once all 3 meters are set to milliamps, click the clamp button on each one to release the clamps. Then place a clamp on the brown line wire before each ceiling rose. This allows us to see how the current changes as the circuit feeds each light point. We can now energize the circuit by pressing C5 on the bus component. Then press the A button to activate the current flow animation and switch on all 3 light switches. You will now see current flowing to each lamp. Using the formula I equals power divided by voltage, a 5-watt lamp on a 230-volt supply draws approximately 0.0217 amps, which is about 21.7 milliamps. We can see that value on meter 3, which is measuring the current feeding the final lamp. Because the other 2 lamps are also drawing 5 watts each, we would expect to see a larger current further back along the circuit. Meter 2 should show the current for 2 lamps, and meter 1 should show the current for all 3. That is exactly what we see. Meter 3 shows roughly 20 milliamps, meter 2 shows around 40 milliamps, and meter 1 shows approximately 65 to 70 milliamps, depending on the exact rounding used in the simulator. That tells us the Megga Meter is behaving exactly as expected. You can move the clamps to any wire in the circuit, and the meter linked to that clamp will update accordingly. You can also add more Megga Meters and clamps whenever needed. Try switching the lights on and off, and you will see the current values changing throughout the circuit, depending on both the load and where the clamps are positioned. If you accidentally delete a clamp, simply press the clamp button on the meter and a new one will appear. And if you delete a meter from the workspace, its linked clamp will be deleted as well. We'll come back to the Megga Meter again in a future demo, but next time we will focus on voltage. Please like, subscribe, and leave a comment below. I'd really love to hear your thoughts, especially if you think this kind of tool could help support your training journey towards becoming a UK electrician.